Thank you very much for joining this second lecture. So the first one, you remember, was an introduction and was a joint lecture also with the open platform category. But here we start a set of lectures that are specific for the standard platform. So again, let us thank SoftBank Robotics for the support in this challenge, and we try to overcome the sanitary situations that do not allow us to do an event with physical presence, but it's very nice, the support from SoftBank Robotics in consider the possibility of running the code from the teams that will participate to the challenge on the robots in their lab and to produce some videos of it. So for this, we will have a two-stage part of the competition. In the first stage, you will submit the description paper in which you describe the experiment and the code. And then in the second part, some of these codes will be run on actual robots, and you will get the video of your code. So even if you will not be able to use the robot during this preparation time, it is still possible for you to write code that will run on a real robot. So in the lectures here, we will focus more on the simulation tools. So all the tools that are available for developing applications for Pepper Robot. And of course, there are some functionalities that is more difficult to test without the actual robots, while other functionalities are easier for you. And so we decided to tailor these lectures on the functionalities that you can actually test on the simulated tools. So the main goal of this lecture today is to explain whatever is needed to write application. So in about 1 hour from now, you will be able to write the first application for Pepper Robot. So here you can see the information, general information about this classroom that should be already available. And of course, if you have questions, then we can go back here. So let's have a first set of slides with an introduction to the humanoid robot Pepper. I'm pretty sure you have seen it already. It's not the first time that you see this robot. Maybe SoftBank can confirm. I think it's the most common robot in the world. So if you have a single robot and you want to measure how many units of these robots are around the world, probably this Pepper is the most common. Of course, a robot at this level. There are many interesting features of the Pepper robot that I'm not going to list all of them here, but I want to focus on the features that are interesting for this particular challenge, and in particular for you as students. So of course, the robot has been designed for many purposes, including business. So there are many business applications and business models around this robot. But here we will use it more from the point of view of the educational, as an educational platform. So for sure, the robot has been designed especially for improved user experience, for social interaction. And you see that the appearance of the robot has been carefully designed in order to attract the users, and all the devices and sensors and the computational power and the development tools that we will see in this lecture are being carefully designed in order to make easy and effective the implementation of interactions with the robot, with the goal of improving the user experience, which is, of course, a very important feature of human-robot interaction and, of course, of the Pepper robot. But again, we will mostly focus on this platform as an educational platform. And so we will see what are the tools that are available for education, even if in this online challenge, we are kind of mixing education with development. Because from one side, we are teaching you how to use the robot. But from the other side, we will evaluate your work in terms of how nice is the interaction, how valuable is the interaction, what is the user experience. So in a sense, we will also be at the same time on the side of the student who is learning this technology, but also on the side of the application developer, because you have to develop the best application, the application that will be evaluated in the best possible way. Okay, again, if at any time people from SoftBank want to add additional information, please go ahead. Now, in the next slides, you will see a few examples, a few videos. Now, I will try to run it. Not sure how good will be the streaming, but in any case, you will have here the link so you can check these videos later on. So this is
You and I have to work together. I would be glad to help. So it's a deal. My pleasure.
okay. I hope the user experience for watching this video was good. If not, again, you can check the video here in this link. So this is a generic video about the Pepper robot. And next, in the next slides, you can see some additional videos of the robot used in the RoboCup at home competition. So the major one, the one that is developed at research level. So in 2016, there's been a call in the RoboCup Federation to select standard platforms. Sorry. There is some background noise. Can you please make sure that your microphones are muted? Thank you. So in this, this was, I think, the demonstration that SoftBank Robotics made at the selection. We had many robot companies that were competing in order to get accepted as social, as standard platforms for RoboCup at home. And at the end, the Pepper robot was selected as a social standard platform. So here again, you will see the video of the demonstration, and you will see some abilities of the robot that have been demonstrated. This was, again, before the actual competition, the RoboCup at Home social standard platform competition.
Oh yes, what do you want to hear this morning? Okay, tell me when you need me again. We should get to the forecast. Today you have to go to RoboCup to present me as the next platform for the contest. Elmer will come in.
Okay, maybe it's not needed that we go through all the video, also because I'm not sure if you are listening correctly the audio and if the streaming is good. So I invite all of you to look at the full video through this link later on. And this is the third video that I will show you now. Is an example of the actual use of the robot during the RoboCup Home competition. So since 2017, Pepper is the robot used in the Social Standard Platform League of RoboCup at Home. And it's been used by many teams, researchers, to develop applications for the robot in a RoboCup at Home environment. So here you can see an example of one test in which the robot is used in a restaurant scenario. Okay, again, please check the video later on, and if you look for RoboCup at Home Social Standard Platform League, for sure you will find many other videos. Okay, so let's go more into the details of the very briefly the technical specifications of the robot, just to understand which functionalities are available, which tools, and we'll see then in the next lectures that for all these devices, we will have the possibility to use it in an application. So first of all, we have, of course, a robot that includes a computational device with this particular processor, CPU. and the connectivity, both Wi-Fi and Ethernet. And inside the robot, there is a computing device running the Linux operating system. But what is more important for us is the software development, because in this lecture, what we will do is to develop software for this robot. Of course, we have to understand what are the devices, the hardware, but we will focus more on how to use the software development kit tools that are available to actually make nice behavior of the robot, like the ones that you see in the videos. So there are two kinds of software development environments for the Pepper robot. One is the Iocchi framework, that is a Python and C++ framework that is available with version 2.5 of the Pepper robot. And the second one, the second environment is the Android SDK, which is available with version 2.9. So in these lectures, we will focus only on the Android SDK version. Okay, so we will explain how to program the robot through the Android SDK. If you have knowledge about how to program the robot with the Python or C++ interface, of course, this is also possible, and we accept teams that will develop their software with the Python or C++ interface, but the focus of the lectures here will be only on the Android SDK. I think that there are other initiatives on the Iocchi version of the SDK, and maybe we will inform all of you later on. Okay, in terms of devices, the robot is equipped by two kinds of distance sensors, a laser sensors that has a distribution frontal and on the sides. So it's there are three sectors of a laser that can detect obstacles on the front and on the left and right side, and these are useful for navigation. And the sonar sensor, there are two sonar sensors, one in the front and one in the back, that is useful, for example, to detect people in front or on the back of the robot. These are mostly used for navigation, which is a functionality that is very difficult to test without the actual robot. So we'll probably focus less on navigation and more on other functionalities. As vision sensors, the robot has different kinds of cameras. There are two RGB cameras, so color cameras, one that is looking frontally, another one is looking downwards. And these are very useful, for example, to detect faces and to recognize people and to check the interaction, to monitor the interaction. There is also a depth camera or a stereo vision camera that can measure depth. So not only the camera is able to detect the colors, so colors are used to, for example, for face recognition or face expressions, or many other tasks that require the appearance of the person. But also the depth is important because it allows to give an estimate of the distance of people with respect to the robot. So with this information and combining information from the color camera with the depth camera, we can improve the quality of image processing. Again, also this component is very nice to be used with the actual robot, while it's a little bit more difficult without the robot with the only simulated tools. What is more interesting for us are all the HRI devices, because we will focus more on the interaction, and so we want to use as much as possible the interaction devices that are available on Pepper. And since Pepper has been designed especially for social interaction, of course, these interaction devices have been designed very carefully. So first device that is easy to see is the tablet, which is on the chest of the robot. And the tablet is very important as an interaction device, both for the output communications, so communications from the robot to the human, but also as an input device, because the tablet has a touch screen, and so you can actually interact with the robot. For example, you can create button interfaces in which the robot will communicate, sorry, the humans, the users will communicate with the robot by touching the screen. Then there is an array of microphones in the head of the robots in order to detect sounds and words by people around. Loudspeakers in order for the robot to talk. Some LEDs in the eyes, in the ears, and the shoulders that are very important for communication. So even if the Pepper face is not actuated, except the head and the pitch, but the colors of the heads are very important. With the colors and with the difference in time of colors of the heads, the Pepper robot can express emotion and can emit social signals. And then there are some additional tactile sensors. So you can touch the head or the hands of the robot, and there are sensors that detects this kind of activity. So there are many devices for interaction, both input devices for the robot to get information from the users and output devices for the robot to send information to the users. And what we will learn in this lecture is how to combine all these devices in order to have a nice multimodal interaction. We will see very soon that it's important for the robot to use multiple modalities during the interaction. And having all these devices is very nice, but also it requires some care about the programming task. And so that's what we will mostly focus in these lectures. So again, if you have questions or you want to add something, feel free to interact through the chat. Okay, let's go a little bit more in details. So the head of the robot contains the core of the intelligence, we can say. There is the system, the operating system based on Linux, that is the main computational device that manage all the devices of the robot, so all the electronics, all the joints for the movement and all the sensors. And the interaction is with mainly with another computational device, which is the Android tablet. So these two computational devices interact together in order to implement and run your behaviors. And the main idea is that the Linux operating system is dedicated to control the basic functionalities of the robot itself, while the Android tablet is more oriented with the user interaction. And in this lecture, since we are focusing mostly on developing high-level applications that are focused on interaction, we will see more how to program the robot from the Android point of view, so from the interaction point of view, while there is, of course, a lot of research and implementation of the basic functionalities, but we will not cover them in these lectures, in this course. Okay, so how it works. When you write a code in which you ask the Pepper robot to say something, you will deploy your code as an Android app, and the tablet will communicate with the CPU in the head of the robot to activate the speakers, and you will hear the sound coming out from the speakers. For the audio input, you will have the opposite. So people will speak, and through the microphones of the robots that are in the Pepper head, the signal will be processed. This information will be sent to the application, to the Android application. And if you write a piece of code that, for example, aims at interpreting the spoken words of the user, this will be available in your Android part of the code. Okay, so we will use all the functionalities of the robot through an Android application. We will deploy, actually SoftBank people will deploy your application on the Pepper tablet, and the Pepper tablet has the functionalities of interacting with the Linux machine in the Pepper head that will control all the functionalities of the robot. Of course, this is much more complicated than what I said now, but this is, I think, what you need to understand in order to follow the remaining part of this class. Okay, the robot has also a set of predefined postures, but also postures that you can define. So in general, there is a working posture, that is the posture in which the robot is standing, and the robot in this posture means that it's ready to start the behavior, to start the task, to start the interaction, while sometime you will have to put the robot, especially the physical robot, because of course you need also robots need to rest. So there is this safe posture, the posture in which the robot is in this down position that is used when the motors are off. So this is very important when you have the physical robot, because this position allows to disable all the power to the motors without keeping the robot stable. Okay, so as a difference with other humanoid robots, if you look for humanoid robots, you will see that all the humanoid robots fall down, and this is a typical feature of humanoid robots. Pepper has been designed in such a way that it's practically impossible to make it fall down. So both in software and in hardware has been carefully designed in order to make sure that it will be safe for people, but also for itself. Okay, anyway, just to let you know, especially if you will be able to interact with a physical robot, that this is the typical position, the standard position, so standing when we want to actually start the interaction, the behavior, and rest posture when we want to put the robot to rest. Okay, I see that there are some questions, but I also see, thank you very much, that people already answered to this question. So I think we can go ahead. And now we enter in the important part of this lecture. So the first part was just an introduction. Now we want to explain what you need to do in order to program your robot. And so in principle, everything is very simple. In practice, it takes a little bit of time and patience from your time. So Make sure to follow all the steps. All the steps are important. Don't be, I mean, it's important to make all the steps, and you have to know since now that this takes some time. Don't worry, it's normal. Okay, don't be in a hurry in implementing these steps. So what we will see here is how to install two components. One is Android Studio. So Android Studio is a general application SDK to develop Android application. So maybe after this course, you will also be expert on Android, and you can develop an application for your smartphone. So Android Studio is a general SDK, and we have to install this first, and then on top of it, we will install the Pepper SDK with a particular plugin, a component of Android Studio that is customized to develop Android applications for Pepper Robot. Okay, so all the instructions are here in this link, and you are invited to follow all these instructions carefully. In these slides, I will quickly summarize what are the main steps to be done. You cannot do it now. Each step can take several minutes, so you have to do it offline after this lecture. And so in this lecture, I will just summarize what are the main steps so that make sure that you understand how to install everything. Okay, so first you have to install Android Studio. And so all the information that will follow are available here from this link, okay? So you first download and install the Android Studio. So Android Studio is available for all the operating systems, Windows, Linux, and Mac OS. Of course, you have to install the specific version for your operating system. When you open the Android Studio download page, you will be asked to select to download the installation setup file for your operating system. Just for reference, I'm writing here what is what are the versions of the, at least of my installation, but also other people in the organization team is continuously testing all the software. So it should not be a big problem if you will install a different version. For example, I just checked yesterday. And so if you, yesterday, the version of Android Studio was 3.6.3. So it's likely that if you install it today, you will get the 3.6.3, but maybe tomorrow it will be 3.6.4 and so on. So don't worry about which version. And so you can safely install the last one. I suggest to do it as soon as possible, of course. This is just for reference. If you really want to make sure that you have exactly the same versions of us, you can install maybe some of the version. The 3.6.3 is okay. Yes, in principle, all the versions are okay. In practice, we never know what happens. Maybe in 2 days, they will release version 3.7 that may be not compatible with some tools. So we will monitor this. And of course, if you have problems, you can contact. But at this moment, there is no problem in installing the last version, except for one point that I will comment later on. Okay, so after you install Android Studio, you will have to do some steps. And at some point, you will be able to run the Android Studio. And at this point, you can start developing Android application for your mobile phone, for example. But if you want to and we want to, of course, develop a Pepper application, we have to install the Pepper SDK component. So there is an option to install the new plugin in Android Studio, and you have to select a new plugin, which is called Pepper SDK. Current version is 1.3.15. Okay, so the first step is to install Android Studio. The second step is to install the Pepper SDK into the Android Studio. And then, okay, here there are some screenshots, but I also have a video about what to do. But anyway, what you will have to do is just to write Pepper here in this text search field, and you will find only one result. If you write Pepper here, you will find only one result of Pepper SDK. You click on install, and that's it. And once you install the Pepper SDK plugin into Android Studio, you will have other functionalities available. In particular, a robot application item in the menu that is used to create new robot applications, and some additional icons in the toolbar that will be useful to start these applications. Okay? So anyway, I will summarize everything later on. After you install the Pepper SDK in the Android Studio, you will get additional functionalities that are useful for developing Pepper applications. After that, you have to install the Robot SDK API, and at this moment, the versions of the API available is version 6. So you will install also this API. So these are the API of the Pepper SDK. And after all this process, you will be able to run the emulator. So the emulator is a virtual robot, a 3D virtual robot that will move exactly like the real robot, but of course just in one window of your PC, and you will have the emulator of the tablet of the robot in a separate window. So what you see here is what will actually appear in the actual tablet of the robot when the application is run on the real robot. So in this way, you can see the application running on the simulated robot, on the virtual robot, and on a simulated tablet. And when this application is run on the physical robot, you will see that whatever the virtual robot is doing here, the physical robot will do, and whatever it happens on this Android virtual tablet, it will actually happen in the physical tablet of the real Pepper robot. Okay, in particular, once you have the Pepper SDK emulator, you will have this button, the emulator button. You can click here and you will have these two windows appearing, or you can go to the Tools menu, Pepper SDK, and then Emulator. Okay, now that we reach this situation, I have to warn you about two possible problems that you may encounter. And one is specific of Windows operating system. It may happen, it's not guaranteed, in case when you run the Pepper emulator here, you get an error and you get a window, say that this QEMU system, blah, 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 has stopped working. Then the problem is that there is some incompatibility of the versions, and you have to downgrade the emulator version to this version here. And practically what you have to do is to download this file here. So you will, of course, have this link on the slides. In case you get this error on the Windows operating system, you download this file and you replace the content of this file with the content of the folder in your machine. This is better explained later on in the video. So just to let you know, if you get an error, don't be disappointed and discouraged. Go ahead and solve the problem. For Ubuntu also there is a known problem. Sometimes, especially in the 18.04 versions of Ubuntu, you may have a problem that emulator is not starting. So when you try to run the emulator here, either nothing happens or you get some errors. And in this case, the solution is again described in this link. So the solution requires some additional installation of libraries and a process of relinking libraries, which is described in this link here. Okay, if you have any other problem except these two, let us know, and of course we'll do our best to solve them. Okay, now what is nice is that everything has been summarized in this video here. That is a video showing step-by-step procedure of the installation under the Windows operating system. So I will not play this video now because it's not needed, but here you have this video that you can use to check step by step all the actions that have been performed. And what I suggest for you to do is to go through all the section, and then maybe, for example, here, it will take some time before the download, so you have to wait and to pause this video. Then you go ahead with another section, and then here, for example, you have to wait again. So consider that this video is 15 minutes long without, I paused all the time for the download. In my opinion, this would probably take maybe half an hour or 1 hour, depending on the speed of your internet connection. And by the way, make sure that you have a good computer with enough space on disk, enough memory, and hopefully also a good graphical card in order to avoid lack of performances. So please go through this video and make sure that you will be able to reach a final configuration in which you can run the here the simulator. So you should reach the situation in which when you click on this button for running Pepper emulator, you see these two windows appearing. This is the first milestone. Once you have this, then we can start writing code and run the code on Pepper. If we don't reach this situation, we will not be able to test the code. Okay, there is a question about minimal hardware and graphical specifications. I don't know if this information are probably available on the, for example, on the Android Studio website. So for sure on the Android Studio website, there are information about minimal requirements. And for Pepper SDK, I'm not sure. Maybe someone from SoftBank can answer this question.
I don't know the minimum configuration off the top of my head. You'd have to try more.
Okay, anyway, for sure there is a setting to use both hardware and software graphical interfaces, so it's not really necessary to have a wonderful graphical card, because everything is also possible to run with software emulation. Of course, the software emulation will be a little bit slower. Okay, what you will have here. As I already mentioned, you will have a virtual robot and the Android virtual devices. These are the most important components, because when we run our applications, we will see the actual execution of the applications on these two windows. So if you write a behavior for the robot to move, we will see the virtual robot here moving. And when we implement code for tablet interaction, we will see the tablet interaction moving here. There are other tools available that we will cover later on in the next lectures. One is very interesting, is a tool that allows to make some animations, to create new animations. I will go quickly through this list of tools, then maybe I will ask Emil maybe to give more details. So the animation editor is to create animations. Here you can see that some of the animations are already available in a library. So you can use these animations and combine animations for creating a more complex behavior. And there is a very interesting tool that is a chat editor that we will cover in one of the next lectures, that allow to design dialogues that would be, of course, very important in human-robot interaction. And a trajectory editor that instead is probably more oriented to the navigation. Of course, it is possible to use this component, because here you see a grid and you will see the robot actually moving if you give navigation commands to the robot. So the robot can really move in this space, but of course this space does not contain obstacles and other elements of the environment, so it can move only in an empty space. But still, if you want to design a behavior of the robot to move both the arms, but also the wheels, so to move the full body, of course you can do it. And the combination of the animation editor with the trajectory editor makes possible to design very complex movements. Now, let me ask if Emil wants to add something about these tools.
Hello, yes, I can just give a little demo of what it looks like.
Okay, so can we do one thing? Maybe I will finish, because I have just one more slide, and then you can take the screen, okay?
Yes, go ahead.
Okay, so just to conclude, I have just one or two more slides. There are two different programming languages available for in Android Studio and in Pepper and DK. One is Java and another one is Kotlin. I think we will mostly focus on Java programming language, but there may be something also in Kotlin. And I would like to also tell you that there is a test activity available on this repository here. So if you go to this repository, you will find an activity for testing and the instructions about how to test this activity. So the main goal of this lecture was to install the Android Studio. If you want to do an additional exercise, what you can do is to go and follow this link follow the instructions in this link about how to take the activity that is here and copy it into your project. And in this way, you'll be able to run the code and you will see the robot doing something. Okay, so this is first item that we put in this repository that we will build during this lecture. So the RC Home Edu Learn Pepper, which is a repository under the RoboCup at Home Education GitHub domain. So we will use this repository to share with you tests and examples of applications. And one is already available. It's the one that is called Hello Human, and will just allow you to try and test your first app on Pepper Robot. And there is this other link that is managed by SoftBank Robotics that contains several other tutorials that we will see during this class. So in these two repositories, you will find code examples, documentations, and you can also ask questions through the GitHub channel. So assignments for the next week, mandatory, install Audio Studio and Pepper SDK, optional, but very much suggested, run the Hello Human app that you find in this link here. And next lectures, so next week we will see how to program an app. So now you will do it by just copying and pasting, but without the explanation, while next week we explain more in detail how to create apps for the Pepper Robot. In lecture 4, we will see how to design dialogues for the interaction between robot and humans. Lecture 5, we will see complex examples in which we put together many items from the dialogue and from other functionalities of the robot. And lecture 6, we'll see a more advanced way of programming the robot in order to create tasks that are a reasonable level of complexity. Okay, so I will leave now the stage to Emil. So I stop sharing my screen and you can take and show some nice use of the tools.
Hello, yes, I have shared my screen. So here we can see the Android Studio with the plugin, as Luca has presented. I just wanted to just give a bit of a live preview. So what we can see here is that here, in addition to the plugin to Android Studio itself, when you launch the emulator, you're going to get two windows. One with the robot viewer, so which is Pepper-like, so you can actually move it around a bit. So here I'm going to give us a better view of Pepper. And you're going to have the Android emulator. So anything that happens on Pepper's tablet is actually going to be shown here. So you can see it better and you can actually click on it, like unlock it or whatever. And actually in the robot viewer, you have a bunch of other views, which, so if you like select a part of the robot, you can have a motion view of it. And the one where I'm going to show here is the dialog view. We'll go into this in more detail in the following lectures. Here I just wanted to show an example of a simple application. We connect to the emulator and we run the application. And so you are going to see it's still running here down there. And this is an application that just has the default Android layout. So it doesn't do anything fancy. It's in Kotlin, by the way. As Luca said, you can do this both in Android and Kotlin. In general, for teaching, we prefer to use Java because more people are familiar with Java and don't want to be learning a second language while they're doing this. But for practical development, we generally find Kotlin to be more convenient. It's a much more compact and powerful language. But you can do anything in Kotlin or Java. Just tend to prefer Kotlin. So here's the example of what the code looks like. Here's going to be launching on the emulator. So installed, it runs. We have the content on tablet, which is just hello world. The blue bar at the top indicates that Pepper is in a listening state. That means I can say hello to her. And Pepper answers hello RoboCup. So here is the dialog view, which you'll probably be using quite a bit for testing anything related to dialogue. So how are you? And so Pepper will answer, I'm fine, thanks. What is your name? My name is Pepper. And the hello is actually the only one that has an animation. So here Pepper is placing an animation here. The code for this is fairly simple. We're going to explain how it works next week, but we're just basically loading an animation, loading a chat topic. A chat topic is a special format, which is basically like for defining a chatbot. So here we define what we say. This is going to be used to trigger an animation. You can do much more advanced things than this that we'll be seeing later on. And if you look in the project itself, we have the chat topic and the animation here. So the chat topic has its own editor, and the animation editor. I'm going to try launching it, but it's actually a separate editor here. So you could edit the animation too, which I'm not going to do right now. But you usually don't need to do so, because when you import animations, when you do file new import animation, you have a huge library of possible actions, like for example exclamation, that you can preview live here and then run on the robot. So that was the lightning tour of running an application on your robot. And I will give the microphone back to Luca now.
Thank you very much. So you see that this tool is very powerful. It's also relatively easy to use, but of course you have to learn how to use it. And so that's the goal of the next lectures will be to go step by step. First in how to develop simple applications, and then we will increase the complexity of the applications over time during the lectures. Okay, so I think that's it for today. I'm sure that you will spend the next hours in installing the Android Studio. Check the video, cross your finger, wait, and let's wait a little bit to answer your questions.
Okay, for the meantime, just announcement that please also put down your attendance, right? You can do it through this link. It will send you to a Google form. Okay, for the interaction as well. So I think the best is like you can join our Facebook page. So inside there, so you like our Facebook page, and over there is actually a Facebook group, right? So please add yourself into the group. I will let you in. Then we can. That is a platform for the interaction among the community. So if you need any more direct, so maybe you can email some of us. But I will recommend to do this more openly so that we can share the knowledge for everyone in our community. Yes, there's a Facebook page called, okay, let me send you the link. So this is the page. So this is the page, and then you head to the page. There's a button there that you can join the group. So you can like our page, and yes, you can join our group. Then that is the our community that we will interact inside there.
Also, an additional announcement is instead for teams. So people who are willing to participate, please fill for the registration information that are related only to the team leaders. So it's important for us to know who are the teams that are willing to join the competition part. So for teams who wants to join the competition, make sure that you fill the registration form. Okay, no more questions? Well, depending on your time zone, good afternoon, good evening, or good morning. And we'll meet again next week for the next lecture.
All right, thanks, Luca, and thanks, everyone. So I put up the last page for reference. So anyone that would like to know more or sign up for the competition, the link is over there, the online entry form, and also the web page for the competition, the online challenge. And also we have the link for the online classroom, which is for this. We will do the same times, and you can find out the Zoom link, and also all the materials, the videos we will post up accordingly on the website. Right, so yes, if you really need to write to us, so there's an email for the OC, but please put it for the organization issue. Anything technical, please discuss in the Facebook group. All right, so I guess it's done from Luca, and also from SoftBank. If you have anything to add or else, yes, thanks everyone. Please don't forget to sign up your attendance through the form list. We need the number in order for us to continue working on this class and also our activities. And with that, I would like to say thanks for everyone to attend today, and also Luca for the presentation, and also email, and also fellows from SoftBank. Thanks everyone for joining, and we will see you next week. Thank you very much.
Thank you, bye-bye.